All right, it's 11:30. Good morning, Øredev. How are y'all doing? Having a good conference so far? Yes, yes. My name is Huyen Dao. I'm very, very happy to be with you this morning, especially to talk about one of my favorite subjects in the last couple of years, and that's Kotlin. So, as I said, I've been doing Kotlin. It's almost like I think my second year anniversary of doing Kotlin, and I still find one of the most difficult things for me is how to write that magical I word, idiomatic Kotlin. And I think one of the best resources for me in trying to figure out what idiomatic Kotlin is and how to write it is the standard library. So yes, using the standard library is idiomatic, but there are so many things that you can learn about Kotlin from like language features, from syntax, from how to build really interesting structures that allow you to write that kind of delightful Kotlin code. And you can find all that out by just looking at the source code, taking a peek, and seeing what you can kind of steal and borrow from the standard lib. So that's what we're going to do today. So I think my first love in Kotlin was the collections API. And so coming from a Java background, I'm an Android developer, and I've been doing Java for longer than I'd like to admit. And I think that there's a lot in the collections API that was fantastic, both as just a Java developer and also as someone who did more reactive style programming. So if you're familiar with RxJava and Java 8 streams, you'll find in the collections API some really lovely familiar constructs, operators, things that are composable, and things that are, and this is one of my favorite words lately, fluent. And what I really like about the Kotlin Collections API is that it's a functional API. So I don't know how many of you are very familiar with or have done much functional programming. I'm not going to kind of go too much into depth with it. But I think generally the grand idea is that when you program in a functional style, you focus on evaluating expressions over executing statements. But really what that means is that you focus on what you're doing and not how you're doing it. You start at high, you speak in high level concepts rather than kind of enumerating very specific, kind of low level statements. And that's really what the Kotlin Collections API is. And if you're interested in functional programming but haven't quite gotten into it, I would highly recommend Functional Programming in Java by Venkat Subramaniam. He's an amazing speaker and instructor. If you've never gone to his talks, I highly recommend it. And even though it's written in Java and this is a Kotlin talk, I would definitely recommend that you read it because it gives a wonderful introduction to functional programming concepts. So, and I kind of stole, again, the word fluent from Venkat. He uses it a lot, and it's kind of an emphasis, I think, on readability and maintainability that we kind of want from our Kotlin. So, all right, so let's take an example. Let's take a look at how awesome the collections API is. So say that I'm a captain on a voyage of discovery, off to discover bold, new civilizations and new planets, boldly going to places that people have never gone before. And occasionally, as a captain of my mission of discovery, I have to send my team off onto missions on some planet. Maybe someone needs rescuing, maybe some technical thing needs fixing and we need to find a thing on a planet. So I need to create a crew for my away mission. And I want my crew to be able to handle different situations. So I want to build a strong, versatile, agile crew. So I might pick different members from my ship. So say I might need someone to lead the away mission. So I might have to go to my command deck and find maybe an impetuous captain or maybe an enigmatic science officer to lead. I might need an engineer. Things break on away mission, so I'll need to find an engineer to help us out. But we want to find someone who's not currently doing repairs. Repairs are important on a big starship. And missions are dangerous. I might need a doctor. Someone might get hurt. So I want to make sure that I find a doctor. He might be ornery, but we have to make sure that he's a doctor, damn it, and not a mechanic. And furthermore, sometimes we need other folks to help along. They often wear red shirts. They tend to die a lot on missions, but we need them. We need the extra hands. So let's make sure that we find a few of these red shirt wearing folks, find some that aren't dead already from a previous mission. And also, let's go ahead and filter our team. It's a tough mission. We want to find folks that are above a certain rank, have some experience. And because why not, let's sort the team based on ranking, see who gets to go off the ship first. So I just told you a lot of things. I had a lot of conditions, a lot of things that are going on, but I was able to write that in code in a very fluent, readable way. It's high level. You can see exactly what I'm saying in English in the Kotlin code. And I think that is exactly what is one of the things that is so amazing about Kotlin is this kind of standard lib and these functional APIs that allow you to do things so fluently. But it's not just that it's some special magic in the standard lib that allows you to do this. They're just language features that the standard lib is using and that we can use as well. So let's take a look at some of these features that are wrapped up inside of the functional API, or the collections API rather. And if we just kind of look in, there's a lot of stuff going on. There's some function types in the signature. There's types with dots. There's this inline keyword. So let's talk about some of these things that kind of allow us to build beautiful functional APIs like the collections API in Kotlin. So higher order functions. So if you've done Kotlin, actually, raise of hands, how many people are using Kotlin in production at work right now? Okay, and how many people have never done any Kotlin before? And how many people are kind of somewhere in between? Cool. All right. So perhaps some of you might have heard of higher order functions, and you might have heard that Kotlin treats functions as first-class citizens, or that they have first-class functions. So what does that mean? So basically that means that Kotlin allows you to, number one, store functions as variables. Number two, pass functions as parameters to other functions. And three, return functions as values from other functions. And kind of the things that allow us to kind of do this passing and storing are this concept of function literals. So basically, a function literal is just a function as a value, as an expression, something that we can pass around, kind of like you typically think with other values, pass them into variables, pass them to functions, things like that. So if you've been doing Kotlin for at least a little bit, perhaps you've heard of lambdas. They're a type of function literal. I double-checked this on the Kotlin documentation, and it literally says at some point that a lambda is a chunk of code inside of curly brackets. Easy enough, right? And if we look here, I have 3 lambdas. I have one that basically checks whether a string is a palindrome. Is it the same forwards and backwards? I have one that checks whether an integer is even. And I have one that takes an integer array and finds the medium of the values in that array. And the lambdas have a pretty similar structure, curly brackets. They have an argument list, a typed argument list, a right arrow, and then the actual function body. And that's a function literal. That's a lambda. There's a couple of things of note that are kind of interesting about lambdas. Number one is that lambdas do have return values, but they're not explicitly stated when you create the lambda. As you can see here, they're generally inferred to be the value of the last expression evaluated in that lambda. And you can kind of see here in my median function, there's actually kind of there's 4 kind of expressions that could possibly be returned as a return value. It's a little hard to see, but here's 0 if the array is empty. The first one if there's only 1, and there's actual kind of calculations of I have more than one thing in there. So something that's really kind of important to know about lambdas is that you can't actually just type in a return statement, because this is actually really confusing. I'd love to have return statements to kind of, define where I can actually return values from my function, but it's not allowed here. And the reason that is that you cannot do and these are known as non-local returns. So basically, the Kotlin language allows you to use the return statement to return from the kind of closest function declared using the fun keyword. And here, there is no fun keyword, so we're not allowed here. And there's kind of specific language design decisions that were made here. And without going into it too deeply, if you think about Java code, usually like in a for loop, right? You can actually return out of a for loop, like you can return from a for loop out of the enclosing function. And then you have other keywords that allow you to kind of break out of that for loop separately from like returning from the enclosing function. So that I believe that the Kotlin designers were trying to mimic that structure a little bit. And that's kind of why returns are not allowed here. But if you really are like me and can't read this, you can do qualified returns. So I can actually add a label to my lambda here, and then I can do a qualified return so that it's not a non-local return, it's still returning from just that kind of local function scope. But if you're kind of like me and you get a little bit kind of really want things to be nice and tidy and readable, that is there for you. So what are lambdas? How are they implemented? Kotlin's a JVM language. What does this look like when it's actually compiled? Well, to do that, we're going to take what I like to call a bytecode break, and we're going to take a look at some bytecode and see what actually happens under the hood when this Kotlin is compiled. So if I open up my example here, oops, nope, wrong one. All right. Here's a very simple lambda. It's an average function. It basically just takes 2 integers, multiplies them by 0.5, and returns the average of the 2 integers as a float. No problem there. So if I take a look at this, now normally what I do when I look at Kotlin bytecode is I decompile it to Java, because I get really intimidated looking at all those machine instructions. So I generally like to decompile down to Java, but there's a small problem when I do that with this example. So what happens is when you define a lambda, that actually gets turned into an internal class. And as you can see here, because my lambda took 2 parameters, it becomes a subclass of function2. And if you look here, this looks like it would be like an instance of my lambda function, but instead it's an instance of null. So in order to actually see what's going on, I'm going to have to go back to my original method. Oops, to go this one, and actually take a look at the machine code. But it'll be okay. We'll get through this together. So if I go down here, you can see in the bytecode, here's bytecode lambdas kt, which is my file name. And then there is my actual internal class that's being created. This average $1 is the internal class which represents my lambda. So anytime you declare a lambda, you're actually creating a class. And if I go down a little bit more, you can actually see, okay, well, this starts to look like my average logic where I'm loading up the first parameter, the second parameter, adding them together, converting to float, and then loading up a constant and then multiplying them. Okay, so there's like the actual body of my lambda. And if I go down just a little bit more, hey, here's that instance. And really, if we look here, all right, that looks a little bit more like we expect. There's a static variable that holds an instance of my average lambda. So under the hood, lambdas are internal classes, and sometimes, not always, they can be instances, just single, instances of that internal class. So those are lambdas. Now, there's actually one other kind of function literal, which I'll get to just a second. But I do actually want to say that if this is kind of interesting to you, like looking at Java, the Java bytecode and kind of seeing the connections between Kotlin and kind of like the underlying like Java code, Java bytecode, Victoria Ghana has done a couple of great talks about it. I would highly recommend them. And I only understood this weird null.instance thing because of her talk. So let's actually get back to higher order functions first, and let's talk about how you can use functions as parameters and return functions as values. So I'm a dev. I'm an app developer, so sometimes I want to track what the user is doing, and maybe I want to run some analytics to kind of see like, oh, did this new feature I implement kind of produce some engagement or some other analytics-y words that I can only repeat as an engineer. So I might write some tracking functions, and maybe depending on the flavor of my build, what I'm trying to do, I might track to a log simple log file for debugging. I might actually write out to a file. Maybe I could send events out to the cloud so that will be aggregated and kind of do some cool analytics things. So I might actually kind of represent that as 3 lambdas: track to log, track to file, and track to cloud. Now what's really cool is I can do something like this. If, say, I want to just very easily at a high level say, okay, I want to track to file, I could write an higher order function. So this higher order function returns a function as a return type. And inside, I have this enum that allows me to kind of enumerate my different destinations for events. And then I'm actually returning a lambda, a kind of function literal stored inside a value from this method. And then I have another higher order function here that rather than returning a function actually takes one in as a parameter. And I will use that tracker, that function literal, to actually do some tracking. And when I call that function literal, presumably a lambda, I can call it like this, very familiar parentheses kind of function call syntax. But I can also, on that lambda object, call invoke. So that's it. Now, it's not just lambdas and function literals that can have this kind of fun with higher order functions. It doesn't have to be a lambda to be able to be used in a higher order function. Say that I actually changed these 3 lambdas just to be regular declared functions. I can go ahead and do this. All right, I'm going to change these to functions. Use parens, close that up. All right, so now I have 3 declared functions rather than 3 lambdas. Now, my higher order function that returns a function is complaining a little bit because these are no longer lambdas, these are no longer function literals. They're just kind of function names kind of floating out there. But I can actually use a double colon syntax, and that actually becomes a reference to a declared function. And now, even though I don't have a function literal, I can still return and kind of reference that function and have it called in other places. So there's a lot that you can do with higher order functions in Kotlin. Now, I kind of mentioned these earlier, but there's another type of function literal called anonymous functions. And if you can see here, my top method here, so basically I have a really silly function that checks a file name and sees if it ends with a certain file extension. So here's a lambda that does it. But here's what is called an anonymous function. So basically, an anonymous function looks very much like a declared function, except that the function name is missing. But you can actually assign that to a value, pass it around. And what's interesting is that an anonymous function actually has a declared return type. And because it's a function declared with the fun keyword, we can actually do a local return here. So to be honest with you, in production, I haven't found too many use cases where I really need to use an anonymous function over a Lambda. Though if you can think of one, please tell me. I think they're really cool. I just haven't personally used them yet. But it's another kind of functional literal that you can play around with. So kind of going back to the standard lib and the cool things in it, I think my second love after the collections API are what some people call the standard extensions. Now, if you've done Kotlin a bit and played around with the standard lib, the standard extensions, as some people call them, are all these kind of lovely kind of actiony words like apply and let and run. And there are these kind of methods that allow you to kind of play with scope and allow you to kind of group code together in kind of different semantic ways. So maybe you might want to use the apply function when you want to initialize an object and set some properties very succinctly. Maybe you want to kind of do some side effects after your initialization, so you might use also. And sometimes you just want to run some code, so you might call run. And all of these really great kind of standard extensions that allow you to kind of put some meaning and put a little bit of, as I love to say, or as everyone likes to say, syntactic sugar on your Kotlin code, these are all standard lib methods. And what's really interesting is that you can really learn a lot about what you can do with functions and kind of creating your own constructs by looking at these standard extensions. So let's take a look at them. Now, I'm not going to go into too much detail about which you should use when. If you kind of want a talk that tells you how to do that, there's a really great talk given at KotlinConf 2017 by my friend Christina Lee, and she goes into a lot of detail and kind of recommendations from her perspective on when you should use what. But you should totally check that out. Now, in kind of trying to figure out what idiomatic Kotlin is, I found myself looking at these standard extensions and asking myself 3 questions. And these 3 questions basically kind of try to pick out what language features are going on in which of these standard extensions. So, and I'll explain these terms if you don't know them in just a little bit, but my 3 questions are, when looking at these, apply, when, let, run, whatever, is number 1, is it an extension function? Number 2, does it return the receiver or a new value? And number 3, do you pass a Lambda or a Lambda with receiver? So just to see kind of what those questions mean in this context, let's take a look at the standard extensions. I'm just copying and pasting the source code for brevity. But OK, so my first question was, is this function an extension? So an extension function will look like something like this. So if you look at run, apply, and also, you have the function name, but then you have this dot, and then you have, in this case, a type parameter. And it could be like any class name, but here is a type parameter. And this is an extension function. And we'll go over what that is in just a second. And then my second question was, does this function return the receiver or return a new value? So looking at apply and also, these are both returning this. So as like a little kind of sneak preview, this kind of class here that is in front of that is prefixing that function is the receiver. Basically, you can think of that function as being called on that receiver. And in this case, in the apply and also, it's returning that receiver object. So that's what I mean. And if you look at, say, run and let, they're a little bit different in that they actually evaluate the block, evaluate the function that I pass in, and return whatever return value that is. And my final question is, OK, is the parameter passed into this function a Lambda or Lambda with receiver? Now, I already kind of told you what the receiver is. It's this kind of type that's kind of hiding right in front of that dot operator in front of that function name. And if you look at some things like run and apply, you can see that, oh, that function type in the parameter list also has that kind of type dot parameter list syntax. And those are Lambdas with receivers, whereas you kind of have the more kind of familiar, regular old function type syntax down here. So let's talk about those extension methods. So extension methods are kind of one of my favorite things about Kotlin. And so if you've been writing Java for a while, you might have, or you probably very well have, a string utils class. I feel like so many of us have written these kind of utility methods that help us process strings for whatever application we're writing. And this is actually a method that I wrote for work. I was trying to kind of make search a little bit more user-friendly, and I wrote this method called remove diacriticals. Diacriticals are more or less accent marks and kind of other kind of modifiers on glyphs. And I wrote this method, and it's a static utility method returns a string, basically does some magic on the string, strips out the diacriticals, and returns you a whole new string that's all kind of diacritical-less. And when I call it something like this, where I call the utility class name, the method, the method name, and then pass in the parameters. Okay, no big deal. We've done this 100 times. But what's really great about Kotlin is that it allows you to write these utility functions, but treat them as kind of what they are. Basically, when we write these utility functions, we're trying to extend the functionality of an existing class, right? We're trying to extend the functionality of our string, and rather than having to write it in this kind of, less fun syntax, we can write it in a much more fun syntax using extension methods. So here I'm declaring a extension method, extension function rather, in Kotlin. So I have here the class that I'm trying to extend, string, and then I have the dot function name, and then the same function body more or less that I had before in Java. And what the really neat part is when I call this, and hopefully y'all have some experience with the kind of awesomeness of being able to call this utility method that you wrote as if it was a method on a string object. And it kind of it's saving you some characters, some kind of gross boilerplate code, and it makes it just a little bit nicer to read. And again, it kind of is still echoing the idea that, okay, I'm extending the function of this class rather than having to kind of, write this kind of external class somewhere. And if you're kind of curious how they work, we're going to take a bytecode break and see what do extension functions look like inside of the bytecode. So if I go bytecode extensions, okay, so here's my same extension method. I just changed the name because of collisions. And if I go ahead and open up the Kotlin bytecode, I'm going to be chicken this time and decompile it to Java. And I take a look at it, and okay, here's the decompiled Java, and it looks just like my original static, string method. And that's kind of the cool thing. We get the really nice syntax. We get kind of like that nice semantic, oh, I'm adding functionality without actually doing anything too crazy. This is just the same kind of Java code that we've probably all written like hundreds and hundreds of times. But what's really nice is that you're really, extending the functionality of a class without, number one, having to own it, and number two, having to subclass it. And, all of these really great other, string utility methods that you get with Kotlin standard library, like is null or empty, code point count. Oh my gosh, if you've had to deal with emojis and worrying about this kind of stuff, you get all these really wonderful utility methods that you see that seem to be attached to the string class, but they're not. They're really just extension methods. And, there are things that you can do on your own. So lambdas with receivers. Lambdas with receivers are pretty interesting. So a lambda very often, has a argument list. Now, what's really cool about thinking back to extension methods is that, okay, I had my string util, my string util method, right? It took a parameter, and then I did some stuff to that string that has a parameter. What my extension function did was to take that string parameter and kind of give it superpowers, and then it became that receiver, right? I was able to call methods on that string as if it was the this inside. It was like I had just created a new class method. Lambdas with receivers are basically that same idea, but with lambdas, with these function literals. You take a lambda, you take one parameter, and you give it superpowers. It becomes the receiver, and then you can call methods inside of that lambda on that receiver as if it was the this inside of there. It's as if you added like a class method to something. So here's another example. So say that I work for a science company, and machine learning is really big these days. So say that I have a science company that wrote this AI that runs tests. My AI is a little bit unscrupulous. Sometimes it runs tests. Sometimes it likes to insult my testee. Sometimes it likes to bake cake, and sometimes it likes neurotoxin. It's kind of a weird AI. But this is the example that we have. So I say that I'm this unscrupulous science company. I ask this AI to run tests on some poor subject. I'm really sorry about the darkness of the example, but say my AI has some test suites. It might run several tests in a row. It might run a test, check the results, encourage the subject if the subject did well, or bake the subject cake if it didn't do well. In that case, I would actually prefer the cake rather than encouragement, but this is what our AI does. And I might encapsulate kind of these different things the AI does as different lambdas. And say I had a higher order method to run these test suites. It might look something like this. I've got some parameters, the version of my AI, the identifier of my subject, who's going to go through the tests, and then this block, which is a function, which is, again, that test suite that I'm going to run on my poor unsuspecting test subject. And inside of this method, I might create an instance of my tester, given the version, and then I'll call block. And my block takes the AI tester that's going to run the test, and then the, again, subject ID. And then I pass those along and call the block. and that's all fine. And there's nothing really wrong with this, but kind of something that you can see here in the code is something that generally happens a lot when you write code, is that you tend to run a lot of methods on the same object, and then it's like object.this and object.that and object.this. So one thing that lambdas with receivers are really good at allowing you to do is, again, allowing you to call methods on an object unqualified. So again, it's like the this inside of the method. So let's go ahead and change all of this to use lambdas with receivers. So I can actually really quickly convert my higher order function. And as you can see here, I've taken that parameter out and made it the receiver. So it actually prefixes the argument list with a little dot. And if I go here to my two lambdas, let's change these to lambdas with receivers. I'm going to take out the AI tester from the argument and move it in front. So it becomes the receiver. And then I need to change the lambdas themselves because tester is no longer a argument inside of that lambda. All right, so I removed the tester because it's no longer an actual argument to that lambda with receiver. Oh, but now I have all these tester objects. So let's get rid of these. All right. And, ooh. All right. So something that's really great that's happened is I've reduced the visual noise, right? So rather than having to repetitively call object.this, because the AI tester is now the receiver, I can call methods on it pretty much directly. And again, that reduces visual noise. And that's great. You might say, OK, well, that's good for improving the readability of my code, but is that it? Well, it's not it. Being able to leverage like these really cool things like lambdas and lambdas with receivers and some of the other really nice kind of syntactic things you can do with Kotlin, you can actually make your code more maintainable and more error-proof. So let me show you something. So in each of these test suites, I have some stuff that I'm doing at the beginning, at the end. Each time I run this test suite, I have to activate my AI and I deactivate my AI. And I'm doing it each single time. And you can think about, say, like when you run a database transaction or when you do like file input output, there's always stuff you're doing at the beginning and always stuff you're doing at the end. And woe be you if you forget to do one of these steps at the beginning and at the end. So what you can do, for example, when you're writing kind of like your awesome new constructs in Kotlin, is to kind of abstract away some of this. And this is like a Venkat Subramanian word, which I love, ceremony. It's stuff that you have to do to get things done, but that isn't really the point of what you're doing. So say I did something like this, where in my higher order function, I delegate away all of that ceremony to my higher order function. I can count on that higher order function to do it, and then I can, when I actually write my lambdas, just write the lambda and then just count on that higher order function to take care of that ceremony for me. And if you think about back to Java world and like things like with try with resources, where when you have like a closable stream and you can rely on try with resources to kind of do all that like maintenance and that ceremony, that's basically what this idea is. And it's called the execute around method pattern, where again, you abstract away the stuff that always has to be done and then let the developer actually define the interesting part. And if you are in Kotlin world, we actually have a try with resources type utility. It's called use. And again, if we actually look into use, you can see all of that lovely stuff we're kind of used to with closables and catching and finally and catching some more. But all of that gets, again, abstracted away. And all we need to tell the reader to do is read text. And you can build these patterns on your own. If you're any Android developers in the house? Android people? Cool. If you look at KTX, there's a lot of kind of these execute around method utilities. Like Fragment Manager allows you to kind of abstract away a lot of the fragment transactions. If you're like me and you're a view nut, there's a lot of like styled attribute stuff. And all of this is done using that execute around method pattern and leveraging lambdas with receivers and lambdas. So are there trade-offs to using lambdas and lambdas with receivers? Yes, and we're going to talk about them. And specifically, let's talk about closures and captures. And to do that, we're going to take a little bytecode break, and we're going to take a look at a few things. So first, what is a closure? This is one of those things that I feel like it took me forever to really understand. But a closure, according to one definition I found, is a combination of a function and the lexical environment within which that function was declared. OK, what does that mean? So basically, when you have a function declaration, there's going to be kind of other values in the scope of that function declaration that you could possibly reach out and access. And what happens is that function is said to kind of close over those values that it can access. And those values that that kind of function reaches out and uses are said to be captured. So your environment is your local variables in scope. Your closure is kind of like that combination of the function itself, the function declaration, and those values, scope values, and again, the capture things. And if you kind of think back to Java world, a lot of times when you say have an anonymous like class and it's reaching out, there's kind of all these rules about, oh, well, they have to be final. And this is all kind of interactions of like closures and captures. And what's really interesting is that this actually affects the efficiency of lambdas. So say that I'm back on my spaceship on a voyage of discovery when some emergency happens and I have to self-destruct the ship. All right, I might write a function like this to send commands to my ship's computer to initiate that sequence. So I have my higher order method here, run commands, and the first thing that I do is I have to provide some crew authorization. I have to have some senior officers kind of, say their kind of, personal codes, and then I actually start the self-destruct sequence, and then I have to get everyone off the ship, so I evacuate, all right? And then, so I have a Lambda here to do all that. So if I take a look at the bytecode and see what that looks like, and open this up here. All right, well, that kind of makes sense. It's not a lot going on, but I had that Lambda, and I had a single instance of that Lambda, and that single instance is just getting called, and passed through the run commands is getting invoked. Now, what if I instead have this, parameter that I passed in seconds till, and that allows me to actually delay the self-destruct so that people have time to get off the ship. That's a good thing. All right, but what does that do to the bytecode? Well, if we actually take a look at the resulting bytecode, instead of an instance, we actually have a new function1 subclass being created every time that we call this. And there's other kind of gross things going on like synthetic methods and bridge methods. So just from capturing a variable, I have kind of dramatically increased the kind of memory allocation used by this method. Now, this is kind of an isolated case. It's not really a big deal. In isolation, okay, and it's not great, but it's all right. But imagine, this is like kind of an inner loop thing, or if you're calling this thing like thousands and thousands of times, or you just happen to call this just a lot. Imagine kind of how that memory can rack up. So lambdas and lambda receivers are really great syntactic tools. They do have costs. And so kind of depending on what your use case is, you might have to kind of think about what those costs are and how you can offset them. And you can offset them, and there are some tools in Kotlin that allow you to do that. And one of those tools is inlining. Inlining is really interesting. Inlining basically allows you to kind of mitigate some of those penalties by basically taking a function and taking the body of that function and then copying and pasting it at the call site. And if you have a higher order function that takes a bunch of lambdas, everything gets inlined, the function body as well as the body of each little lambda that you pass in. And to see how that actually kind of alleviates some of those lambda costs, we're going to take another bytecode break and see how inlining works. So, all right, so this is different. I'm a security guard. I work at a child's restaurant at night, and for some reason the child's restaurant is haunted. I sometimes have to close doors. Sometimes have to check the halls with my flashlight just to make sure that everything is, the dolls and the animatronics are staying where they are. It's a really crappy job, but this is the job I have. And I might write that crappy job as a Kotlin function in this way, where I have a higher order function that is my work shift method or function, and then I pass to it a block that basically is encapsulating all the things I have to do my job and survive the night from all the haunted things in my scary child's restaurant. And I might call it something like this. So I'm calling my lambda here. I pass it I'm calling my higher order method. I'm passing in a lambda, and then here's all the things that I have to do inside of that lambda to finish my work shift. So if I go to the bytecode and see what that looks like. Okay, it looks kind of like how we would expect. I have my higher order method, and then I'm calling it here in main, and then I'm passing it my lovely null.instance of my lambda that's existing somewhat there in kind of bytecode world. All right, no big deal. It seems all right. Now, if I go back to my example and just add the inline keyword to my workshift function and decompile again, you can see that, oh, interesting. So rather than actually calling my higher order function and passing in my instance, which also gets called, the body of that lambda actually gets copy and pasted, and also the body of my higher order function gets copy and pasted more or less into my main function. And so there's no extra class from the lambda. There's no memory allocation here. There's no risk of having a capture and having this be instantiated constantly. It's just there. And that, again, this is one way you can alleviate kind of some of those kind of like allocation rules from Lambdas. Now, this does have its own caveats in that if you start doing inlining everywhere, you can start running into code bloat. So it's always kind of like, again, those compromises we make as developers, just to kind of where do we want to pay the price and how do we want to kind of trade off like nice syntax versus, efficient code. So just to be aware of that when you're working with inlining and higher order functions. But actually, if you look inside of the standard lib, a lot of the methods, apply, let, run, a lot of the collections API are inlined. And there are some things you can do to kind of make inlining a little bit less painful in some situations and a little more interesting. So there's some extra keywords that go with inlining. So what happens, as I mentioned with inlining, is that the function body of the method, as well as kind of like the parameters that go into it, all get inlined. Now, that's kind of cool, but it also has some side effects. What happens is, because everything is inlined, I can't actually take any of those lambdas and store them into a value. Because this is inlined, it will prevent you from actually kind of treating it as like, a function literal and passing it around. So if you have a higher order function that you want to inline to kind of reduce some of those costs, but you still kind of want to treat some of your parameters as lambdas that you can pass around, you can use the no inline to kind of mark that parameter as being not inlined. And then you can still kind of take that, well, actually, that's not very lambda. You can still kind of store that particular parameter in values, call it later if you wish. So I mentioned before kind of how you couldn't do non-local returns. You can actually do them inside of inline functions. If I actually bring this back up. Say like in my scary kind of haunted children's restaurant, everything for some reason is battery operated. I don't know why. But let's say that if I kind of don't have enough battery to operate anything, I'm just going to get out. Like, I don't need this job. So if I actually had an uninlined function, it doesn't let me do this because, again, because of lambdas and kind of like non-local returns, it won't let me do it. However, if it is inlined, it will let me do it. So the whole part of the reason that kind of it's hard to kind of allow non-local returns from lambdas is that because of the fact that we're kind of storing lambdas in variables and allowing them to be called in different places, what if you call that lambda way later when that original execution context where you kind of define that lambda is gone? What does that return mean? So it's kind of partly why you're not allowed to do it. But with inlining, because you're basically copying and pasting code, it's not that that lambda gets called later, it's getting called now, kind of because everything is being pasted in, so you're allowed to do non-local returns. So what happens is that's not always the case. There's sometimes when you have a higher order function like this one, and you're passing it a lambda, but you're actually putting that lambda inside of something that is explicitly getting called later. So like runnable, right? We usually have runnables to run things later. And in this case, I have this lambda that's going to get inlined into my runnable. Now what happens is, because this runnable is probably going to get called at a later execution context, it actually won't let me do return here because of this cross inline. I'm basically saying, hey, just letting you know, compiler, that this particular lambda could be used somewhere where it could be called in a later execution context. And so the compiler's like, all right, well, just make sure you don't return there. Now, I could try to say, oh, well, what if I just don't make it cross inline? The compiler's like, no, I got what you're doing here. Because it explicitly is used in a place where it could get called later, the compiler won't let you do this because of the possibility of non-local returns. So the cross inline is a good way of you kind of being able to use inlining, but still having runnables and other things that will get called later in with your higher order function. So another thing that's really great with inline functions is Reified. So Reified is a really interesting thing when you have generics and type parameters. So you actually can't do something like this generally. Like for instance, in Java, because of the way that kind of generics and type works with type erasure, where the kind of type information is erased, you can't actually do runtime checking of type parameters. And generally, you can't in Kotlin either, unless you have an inline function and you specify that this parameter is reified. And basically what it does is it tells the compiler to kind of rearrange the bytecode so that you can actually access this type of information at runtime. And that's because, again, it's inline, so it's actually, the code's in place, the compiler will be able to tell what the type actually is, and you can do really cool like type checking against type parameters like this, which you really couldn't do in Java. Now, just a couple other things. Reified inline functions can't be called from Java just because of that kind of weird magic that needs to be done. Normal inline functions can be called from Java, but they're just not inlined. So just to wrap up, a couple of other just random things that are standard lib things that I kind of discovered that just maybe kind of really like Kotlin a lot. I remember kind of first starting to use Kotlin and seeing this like to operator. Oh, well, that's really cool. It's an operator that allows you to kind of create a pair object with this very natural syntax. And I remember very distinctly Googling Kotlin to operator and getting really frustrated because I couldn't find it. And the reason that is that it's not an operator, it's actually a function. And what happens here is this is actually using a language feature of Kotlin called infix. And what infix is that if you have a class method or an extension function that has one parameter, you can actually add the infix keyword to that function declaration, and that allows you to call it without a dot or parentheses. So if you've kind of used down to, or if you've used the shift right operator, they're not operators, they're infix functions. And what's really cool is that you can use this yourself to write kind of really interesting code, that, I mean, it seems a little silly, but kind of imagine like when you're writing something, again, if you can write something more fluently that reads like language, it becomes more maintainable and kind of easier to follow. And there's just really cool things that you can do. Another really interesting thing that you'll learn from looking at the standard lib is about this idea of conventions. So Kotlin has conventions that allow you to access language features by basically naming things in a very particular way and using a couple of keywords. So as opposed to, say, grabbing functionality by implementing an interface or subclassing, some other class, Kotlin allows you to do things with naming. So if you are like me and you used to be in C++ world and you really miss operator overloading, you can kind of get it in Kotlin. And the way it's done is through conventions. So here I'm kind of a space commander and I'm off to save the world from a galactic threat, and I'm putting together my ragtag team of like adventurers to kind of fight this threat. And I can very easily put together my squad using a plus equals operator because I was able to operator overload by very specifically declaring a function called plus assign. I add the operator keyword, and that allows me to basically call that function using a plus equals assignment. And if you've looked at destructuring declarations, which is basically where you can declare variables by kind of pulling out properties from another object and kind of directly assigning those values into values, that's also done with conventions. If you've played with delegates at all, delegates are basically ways of you kind of overriding the naturally generated getters and setters from properties in Kotlin. You can actually override them and add your own custom logic and do all kinds of interesting things like make your code a little bit drier. Those are done with conventions. You basically have a certain function named get value, a certain function named set value with certain signature, an operator keyword, and it allows you to kind of do these really cool things. So just to wrap up really quick, I know I'm almost at lunchtime, contracts. Contracts is like my latest thing and something I just really just discovered in standard lib. So a lot of times, if you were on 1.2, if you're on Kotlin 1.2, you might have run across something like this. I've got a method, I've got some preconditions that I'm checking. I require that this value is not null. And even though I'm specifically doing this preconditions check, Kotlin is still making me put the null safety operator here. And that's because the compiler, at least on 1.2, couldn't tell that, oh, it really should not be it should be non-null here. The compiler just didn't have kind of the information to kind of make that distinction and do the smart cast. But if you're on 1.3, you have this thing called contracts. And contracts are basically a way to kind of inform the compiler about how a function behaves. So if I go on 1.3, I can actually, remove that. And because of contracts, and I'll go in, there's this construct. And basically it says, okay, if you have this method, actually it's down here, if you have this method and it returns, then I can promise you, compiler, that this parameter value is not null. And so that allows the compiler to kind of make the smart cast here because it knows, all right, I got here, require not null must return, so that means that my sphere object here, or sphere parameter here, was non-null. And you can actually use this to create your own really awesome constructs. So this is something that actually happened to me at work. I had a higher order function that I wanted to use to kind of pull some values out from configuration and assign them to kind of one-off vals. And I got this error, which is captured values initialization is forbidden due to possible reassignment. Now, the reason that the compiler doesn't like this is that in my higher order function, I could have done something like this, where I called the lambda twice, which means that any vals that I'm assigning inside of my lambda or my block, I'm trying to basically end up trying to assign a val twice, which is why the compiler was like, no, please don't do that. But with contracts, if I do something like, let me see, where is it? Something like this. And if I add a contract where I basically am telling the compiler, look, compiler, I really promise that I'm only going to run this block once, and I have to add some annotations because it's so experimental, you can see that the compiler error goes away. And basically, the compiler says, OK, you run the block once, so I can say, all right, it's totally safe for you to assign a val. And I just think that's so awesome. And so this is just something that I discovered looking in the standard lib one day and said, oh my gosh, what's this? And now it's at 1.3. And it's just another example of the many tools and awesome language things in Kotlin that can allow you to write these really awesome, fluent, sexy syntaxes. So I would highly encourage you to look in the standard lib yourself, find out what you love and how it's done, rip it off, make it your own, and kind of make your Kotlin a little more idiomatic. I apologize for running over a little bit. Enjoy your lunch and enjoy the rest of Øredev. Thank you.